Welcome to this tutorial. In this tutorial, we will see what happens when we don't use inheritance or polymorphism abstraction where we should use them and what are its consequences. So we will do this by observing a bad example of a code, and we will see how much effort we had to do in this code if we have to introduce more classes or if we have to bring changes to the code. On the other hand, we will see by simplifying the code by making a new code from scratch that uses inheritance, polymorphism and abstraction. We will see how using these principles we have simplified our work. So if we have to introduce changes to our code or if we have to extend our classes, how easy to do it if we are using these principles. So without a further ado, let's get started. So we have a class circle here, and we have a class rectangle, and we have a class triangle, and we have a class figure. So there are total 4 classes in our code, and upon first look we get the idea that they are shapes, right? Class circle, class triangle and rectangle, they are shapes. But are we sure do we want to use inheritance, or how do we know that we want to use inheritance? So we observe the code carefully. We see that a circle has a constructor, it has some data members, and it has a draw function, it has an area function that returns the area of the circle. We see that rectangle also has a draw function, it also has an area function. Same goes for triangle, it has a draw function and it has an area function. So when the classes are related in a way and they have common attributes or common functions, right here we have common functions, but they could also be common attributes in each of these classes. That would mean that inheritance need to be used here as well. So what happens if we are not using, this code is working right here. Let me show you the output. So it's passing 3, this should be the radius of the circle, and 1 should be the height and 1 should be the width. And for triangle, what are our data types? So 4 should be the base and 5 should be the height. So when we try to run our function, let's run it. Fun terminal G++, bad code, alright, and errored out. So when we run our code, we get the output 44.26. So basically the name of the shapes should be returning from the display function, and the figure dot sum right here, it has an iterator that is going for each of these classes separately and calculating the area of each of these shapes and returning the sum of all of these individual shapes area. So this code is working. So why do we need to introduce inheritance when this perfectly fine piece of code is working? So the basic idea is that when we want to introduce more classes or we want to introduce changes to our code, it gets really difficult if we are not using the correct object oriented principles. For instance, if I want to introduce a new class, for instance I want to introduce a class oval, and we have its data members here. Okay, we have its data members here. All right, so we would make its class, we would add a constructor, we would add these functions like the rest of these classes. We would add a draw function, we would add an area function, we would add its constructor, right? But where does it get effort to bring in a new class? This was a pretty simple task to make a class, to add its respective functions and add its data types, right? But the difficulty we get is here. So when we are using other classes or other functions that is making use of these other classes, triangle, rectangle and circle, and now we have introduced a new class oval. So what happens is we want to edit this figure class as well. We would generally go on to make a new list, oval pointer, and is oval, right? We would do something like that, and we would have to make a new function for each of these for each of these requirements as well. For instance, we have an add function for a circle where the circle is being pushed to the back of the linked list. If you don't know what a linked list is it's okay, I will introduce a linked list in other videos. Basically you can think of it in terms of like an array, but it has better time complexity. Unlike an array, it cannot be accessed randomly. To access elements of a linked list, you have to go one by one to the linked list. You cannot access a random point in the linked list. So that is basically the difference between an array and a linked list. So back onto the code to introduce another new class to the our set of code, our system of code. We would have to make new function. We would have to make another function here, void add oval star o, etc. And in here we would want to make another for loop to access the data types, to access the draw function of the oval code. So we would make another for loop here for it4, right? it4 is equal to so we will not it4, first we will make our iterator oval star iterator it4 it4, well, it doesn't matter, but all right. And then we will make a for loop, and then we will call the draw function. So here our work is getting more and more. So similarly in the sum function, we would have to make another iterator, and we would have to call the area function of the oval class as well. So to introduce one class, we have to make changes in so many code. What object-oriented practice says is you can just make the new class and the rest will take care of itself. So for instance, if we had more functions here, or if we had more classes here that were utilizing these triangle, circle and rectangle classes, in all of these classes we would have to manually add the oval class as well, and in each of such functions we would have to make functions for oval as well. So this isn't an object-oriented practice, and we have seen why it gets difficult to make changes to our code using if we don't use object-oriented practice. So now we are going to make another code from scratch, and we will see how using different principles of object-oriented programming such as inheritance, abstraction and polymorphism, we will see how we simplify all of this work. And when we introduce a new class in such a code, we will see how minimal effort it takes to add the class to the system. So let's begin.